And thank you everyone for attending this morning. This is, again, another very exciting day for us and hopefully for you as well. So today, the new next normal, and today it's about data changing how we work. So we're very excited to move forward with this, and again, really appreciate completely that you are able to participate with us, and hopefully that you'll enjoy this session as well today. Again, I would just like to recognize, as we did yesterday, that CIDCI has now moved into, the participants here today are both local, national, and international. So we're very excited about our own opportunity to have participation at such a large scale. So innovation, the challenge of innovation really has never really been greater. And so this, I think, and hopefully you will find today is another catalyst, another stimulus to start thinking about innovation and the things that you're doing as we move forward to make a difference and to accelerate change and innovation into the design and construction industry. A little bit about CIDCI in that in the last 6 months. So we have moved to a series of online salon series where we've done 13 webinars. Most of these are available on our website. And so we would just encourage you to see how we've moved forward in this COVID-19 time to try to keep our mission going and keeping people apprised of the opportunities for innovation. Also, we have an innovation lab where we've had roughly 35 participants. We were able to do that this year. So this is, again, very important as it starts to get people to really think within their organizations, how do they actually think more formally about innovation? The CIDCI board members, we've been making some changes within the CIDCI. And I think it's just really important that we would like to really thank and have tremendous gratitude for 4 outgoing board members that have been part of this organization. So with that, I'd like to basically announce Renee Shea, Chris Lukeman, Nikki Dennis Stevens, and Eric Raff have been participants as board members here. And we'll be leaving the board, but hopefully continue to participate. Our sponsor today is Convergent Technologies. And we would like to thank all of our sponsors as we move forward. So with that, I'd like to turn it over to Chris Lukeman and move forward from here. Thank you very much.
Thank you so much, Stuart. Thank you very, very, very much. And it's great to see everybody back here, and at least to see your names. You don't see everybody yet. So my name is Chris Lukeman. For the past 20 years, I was at Arup, their global design engineering group, and as the head of Foresight Research, Innovation, Incubation, Ventures, and various bits. Now I moved back to my alma mater in Switzerland to be in the office of the president leading strategic foresight. And it's been a great honor to be part of the CIDCI family for the past 10 years. And I'm looking forward to helping today. Yesterday, we had a really fantastic panel. No pressure on our panelists today. We had a fantastic panel. James Pierce from UCSF talked about how he turned their focus to developing really capacity to deal with COVID-19 in March. A really 100% focus on that. And the question to everybody was, COVID-19 is on all of our minds. What has it meant to us? Larry Kohler of Sutter, he noted their intensity and their increase in efficiency. And this I've heard a number of times, how going the Zoomification has in some ways led to increases in efficiency up to 20, sometimes 30%. And that in many instances, Larry was saying how the regulators and building officials actually really tried to be helpful and understanding. And I know that's actually not an oxymoron, building official and helpful, because we all know many really do truly try to help us, but he noted that they really were with sympathy expediting what we were trying to get done. Joel from UC Davis talked about I loved what he said, their 3-day express conversion to extreme lean. And I thought that was interesting. And I noted they felt stretched and they were very proud to have delivered on what they were being asked to do. And Pete from Kaiser talked about their really wide-ranging program to explore how to turn just about anything in the Kaiser campuses into ICUs, from offices to parking garages. And thankfully, didn't need to do that. But the exercise being, well, what if? And to me, this is so much about what CIDCI is about. It's kind of asking those questions. Well, what can we do? What should we be doing? What must we be doing? And it was a great feeling of sharing yesterday. And as was noted, more questions were raised than answers. And we're going to hear today, hopefully, when this question of data, maybe more answers than questions, we'll find out. But some of my favorite quotes there yesterday: what will the waiting room of tomorrow look like? What is healthy aging mean in a digital world? What will COVID-19 compliant hospitals need to look like? How do you need to be able to rethink projects that are already commissioned and already underway? And how can you actually socially distance on a construction site, right? And this is very interesting questions. And my absolute favorite quotes were, as Larry said, I will probably never be back in an office full time. And that makes lots of people pause to think, what does that mean? How many of us are trying to deal with being at home in an office? James said, when it comes to telemedicine, we've been pumping around with this for about 20 years, and all of a sudden it seemed like in 3 days, the graph went from a little bumpy line to an absolutely vertical curve, with no curve, a vertical line. And he said, we're just trying to keep up with the whole issues. And Pete said, I wonder when we're going to outfit our homes with the same quality monitoring as we do for diabetics. Or we know our blood sugar with diabetic monitoring almost every few seconds. When will that happen at homes? This is around data. And finally, we have now proven, Joel, I believe, said, we've now proven that distributed working is viable. The digital transformation happened and seemed like in weeks globally. So yesterday was a really wonderful opportunity for sharing. And to me, the CIDC newsletter offers that for us, for you, to be as a member, and we have free online webinars for all the community of innovators who we have together here now, and those who are not on here. But if there's anything you'd like to know during this webinar, please pop your question into chat. Okay, this is where they're going to be captured, and don't wait until the very end. If you hear something, pop it in, and then we will take care of that, and we will be feeding those to our panelists in due course. So now, without any further ado, it is really my pleasure to introduce CIDCI board member, and I think one of the founding members, Zig Rubel, who's going to be managing and moderating and curating the panel and the rest of our time this morning. So Zig, over to you.
Thanks, Chris. Appreciate the introduction and reflection from yesterday. So the reason why today's topic is about data and not technology is that data, we feel, is the seeds for innovation. So while yesterday was all about questions, today's presenters are going to be showcasing their amazing technologies in the design, construction, operations, and resiliency phases of building, and show how that data transforms into innovation. So I'm not going to talk for that long. So I'm going to ask Jim Peraino of Spatio Metrics to talk about how they're using data to innovate the design process. So Jim, can you start sharing your screen?
Sure thing. Great. So hi everyone, my name is Jim Peraino. Thanks so much for having us here today to talk. I think it's a really important thing to be talking about how data is impacting the whole industry, and glad to have the chance to talk about how specifically that's the case in the design process. So I'm the co-founder of Spatio Metrics, and we're a startup out of MIT that came together around the notion that if we had better access to data during the design process, that we could fundamentally improve the ways that buildings affect our health and well-being. So along with my co-founder, Sonal Singh, we've assembled a team that's really multidisciplinary, bringing together experience in architecture, data science, machine learning, real estate, business development, software product management to tackle this challenge. And as a software engineer and licensed architect myself, I've seen it over and over again, that the buildings we all live, work, and are now slowly reconnecting with each other in have a profound influence on our everyday well-being. But these buildings can really be doing much more for us. In the last 10 years, the AEC industry has shown us that by measuring and predicting environmental performance before a building is constructed, we can drastically reduce energy use. But now the industry is starting to seek comparable standards when it comes to designing for human health in those buildings. And so, as we see it, architects are being challenged to design, iterate, and build spaces in ways that go well beyond what a typical design practice does. And without the right tools, they can't reliably predict the performance of health in their buildings to drive design decisions. What this means is that their customers can't optimize for their own organization's goals, and that's reducing whether that's reducing patient mortality in an ICU or improving collaboration in an office. In the end, this means that all of us are less healthy, productive, and collaborative in these spaces than we could be. And so the practice of data-driven design has evolved to address this problem, and it isn't new. So in the last few years, the AEC industry has acknowledged that data-driven design can save time, save money, and save lives. So for example, in a hospital, research on existing hospitals has shown that whether or not a nurse can see into a patient room in an ICU can actually affect mortality rates in that room. With that knowledge, architects and owners can work together to set design goals and design briefs that prioritize nurse supervision in a hospital layout. And then they can intentionally iterate towards maximizing this metric over the course of the design process. So using data-driven design to measure nurse supervision ensures that the medical team isn't working against the building limitations, but rather that the hospital layout is doing its part to manage patient mortality. And it's not that data-driven design doesn't exist, it does, and it's powerful. It's just that current approaches have really high barriers to adoption, and we're missing out on taking advantage of its full potential because of this. So that's the hurdle that our team is trying to overcome. So Spatio Metrics is a spatial analytics company that democratizes data-driven design to help architects and their clients design and manage buildings for human health and well-being. Instead of relying on expensive consulting or in-house R&D, what our solution provides is economical. So it's easy to use out of the box across projects. Doesn't matter if it's a small project or a large one. It's easy to use in existing no-code workflows because architects typically aren't data scientists, and it needs to kind of fit into their existing workflows. It needs to create a common language between design decisions and facility performance. And it needs to be standardized in a way that enables learning across projects so that we can push the industry baseline forward. It's really important to note that this isn't typical, that generating this standardized structured data across every project we're working on is what's really going to move the needle on our ability to learn from buildings and ultimately to improve them. So the way that it works is that an architect can upload a floor plan, and then our software automatically analyzes it to assess for more than 200 aspects of design in every room, creating a structured data set and then usable feedback that goes along with that. And this is new because this data feeds into visualizations and scorecards that can be customized to allow architects to guide the design narrative according to client priorities. And basically what's normally takes an architect 40 hours of manual analysis or $6,000 to $10,000 in consulting per iteration is now at the designer's fingertips so that they can better spend their time on designing and achieving client goals with a powerful automated feedback loop. And this is new because typically floor plans live on a server somewhere in PDF, CAD file, or in the best case in a BIM file. And while all of this is technically data, it's unstructured, meaning that we don't have access to the metrics that capture the qualities of space that actually matter when it comes to improving health outcomes. Things like visibility, privacy, and daylight. In a BIM model, we might have the construction elements, but not really what the sum of those parts equate to. So when we work with clients, with hospitals and their architects, we've seen this data help with cost efficiencies in delivering layouts that will lead to better health outcomes. So as an example, we worked with the Beth Israel Deaconess Medical Center, which is one of the top 50 US health systems, as they planned to transition for their first new inpatient building in 20 years. And our software saved over 100 hours of design analysis over the course of the project. And the Beth Israel clinical operations team could demonstrate concrete design improvements in an increased nurse supervision, improved patient wayfinding, and reducing travel distances between patient rooms and nurse stations. So these are design improvements that will continue to pay dividends in operational efficiency, reducing staff burnout, and providing a better patient experience year after year through the 20 to 50-year lifetime of the building. And so, this data allowed us to talk at a high level to get an understanding of each facility by looking at a cross-section of the metrics, but it also enables deep dives into specific factors. So in this case with Beth Israel, the clinical operations team really wanted to get a handle on how the new layout would affect the way they operate in their space. And by combining a typical choreography of nurse movements, so, for instance, in a shift, a nurse will go from a nurse station to a patient room X number of times, from a pharmacy to an equipment room X number of times. By combining that with the travel distances, we could help the team visualize how much time a nurse was spending on each leg of that choreography based on the dimensions in that layout. And so you can see here that in the old plan, the majority of time was spent going in this kind of one group, going back and forth between the nurse station and the patient rooms, which, it was kind of centralized to one location. But that by focusing on reducing that one metric by providing decentralized stations, that they could reduce the amount of time a nurse spent traveling in each shift by 45 minutes. So that's time that can now be spent providing patient care instead of walking. So we started on healthcare first, but as you might imagine, over the past several months, we've been called on to repurpose many of the analyses in response to the pandemic. And we've been adapting and applying our data-driven approach to analyzing for health and safety in offices as facilities teams plan for employees' returns. And so we've been looking at obvious metrics like the 6-foot bubbles to keep people apart, but also looking at a suite of other metrics like which desks are most exposed to foot traffic as people move through the office, or how easy it is for employees to get to sinks or to sanitizer stations. We've launched an open source tool to empower designers to help small businesses with reopening, and heard stories of it being used to support schools, restaurants, other businesses who didn't have the means to evaluate their spaces for social distancing on their own. And so this open source tool is available. If you're a Grasshopper user, you can download it here. I'll post this link later. Yeah, I can post it later. Since releasing the open source tool back in May, we've launched a more comprehensive diagnostic that analyzes office floor plans for metrics like traffic patterns, capacity, density, and where it's been available, we've actually integrated sensors to inform the simulations. So what I think is really exciting about this is that for the first time, we're getting really short feedback loops where we can analyze a floor plan, generate the data, but then take in real-time data sources like from these utilization sensors and allow for kind of micro changes or A/B testing within the workplace like hasn't been possible before. Ultimately, our goal is to really address this architectural data gap and by analyzing floor plans in a structured and consistent way, build up this unprecedented spatial data set that can be combined with outcome data that architects' clients ultimately care about. So we can improve design standards and learn how to do things better the next time around. And anytime you're bringing together more and more data, you really need to think about ways of making it actionable and making sense of it and surfacing the most relevant information. And so that's why we've been looking at different data science and machine learning networks like this neural network that you can see here that takes architectural characteristics as an input and looks at how it's related to the organizational KPIs. So whether that's health outcomes or patterns in retail space. So we want to use these to recognize patterns that might otherwise be missed, ultimately allowing us to work towards an understanding of how different designs will lead to different health outcomes or to different outcomes. So at its core, this model allows us to pull in spatial data, sensor data, and organizational outcome data into a centralized source, and then feed back the relationships and insights from this data in time at the moment during the design process or during the building operations that it's most impactful. And it's a model that's relevant to healthcare, where the results are critical enough to make the difference between life and death. But it's one that we see as being relevant across typologies, whether it's optimizing a workplace for collaboration or schools to foster learning and growth. So just wanted to mention that we're beta testing our next generation of software soon. So please reach out, my email is here, if you're interested in testing it out or learning more. But for now, I think that this is our take on how standardized, meaningful, accessible spatial data can really usher in the next generation of data-driven design and lead to a future where every building makes us healthier. So thanks, and we'll look forward to continuing the conversation.
Thanks, Jim. That was awesome. I think if it's okay, you could share the links for the downloads in the chat box.
Sure,
So,
yeah, I'll do that right now.
Attendees can access it. That's very kind of you. Next up is Tom from Civ Robotics. And the idea is now to talk about how data is going to transform its use in the construction of buildings.
All right. Hi, everybody. My name is Tom Yeshurun, and I'm the CEO and founder of Civ Robotics, and we're automating land surveying services and infrastructure projects, but taking the blueprints and putting it in the real world. Infrastructure projects are usually delayed, 90% to be precise. And this is mainly because there's a shortage of skilled labor, marking mistakes lead to reworks because the data is not provided correctly, and instructions are just not clear. It can be unclear on the blueprint, on the stake, or even in the actual design that they're using. Are they using the right, the most updated blueprints and files? That's an issue that comes often during construction phase. And surveyors hate doing this task. Surveying crews have told us this over and over because it's so tedious. On one hand, it's very repetitive. Sometimes there's so many details they have to convey in the real world. And each take includes information, instructions, and they have to convey that by writing it on the stake itself with a Sharpie or with a number that refers to a table sheet that is later sent to the customer with clear instructions for the builders. So this is very tedious, as you can see, and it's done manually day after day. And we know this because Liav and I, the founders, come from this space. We worked in this space in project management of infrastructure projects, roads, rail, ports, and really suffered from this problem, which is why we got the best talent out there in the startup nation from Israel. We're an Israeli startup with a US presence already to solve this with precision and speed. And we've been doing this for the past 2 years. So without further ado, I'll show you now our systems in action. The first system that we've deployed is the drone that uses the same advanced GPS technology for navigation, for landing above the coordinates. And after landing, while taking into account all the terrain parameters and the drone itself, we load a stake from the magazine, and using our marking correction algorithm, we physically drill the stake into the ground, achieving 7-inch accuracy. By using the same technology as surveyors today, but instead of guiding people, it guides our robots. So in this video, you'll see the marking in the ground with spray paint and our stake bullseye in the middle, just to convey to you the level of accuracy that we have achieved. And we're doing this not only in soft soils, like you see here in the farmland, but also on hard soils, even asphalt. By making a pre-drill hole into the asphalt in this case, and later placing the plastic stake into the pre-drill hole, and using the stake design and threads that actually melt into the pre-drill and act as glue. And we've deployed this in a bunch of job sites. And we've noticed that a lot of our customers also do markings with spray paint, like I showed in the beginning. And the corners are usually very close to one another, which is why we've developed CivDot, the sidekick, that lays out the blueprints in the real world in real scale. On this use case is for a road closure. At first, the client asked us to lay out points. And when we asked him, what is it for? He said, it's for striping. I'm like, I can do the whole stripe for you if you want. So by doing this with our robot, we were able to shave off hours of work for his crews, for the safety, and to open the road sooner rather than later. We also deployed this on data centers for foundations. At this job site, it was a 10 by 10 grid, and we just took the blueprints, put it in our software, and press start. The robot just started laying out points, and every 600 points, we had to swap out the can. That's it. At peak, we got 10 points per minute. I would say, to be on the safe side, about 3,000 a day. In solar farm, we use a mixture of both because the corners are so close to one another. So we have the ground robot spray paint, and the person walking behind it hammer the stake into the ground, therefore achieving high accuracies, quality, output with a stake in the ground. And this is very efficient, as you can see. So going back to our presentation, we've already deployed this technology, as you saw, in various job sites. And in a solar farm is a great example. On this job site, they had 4 surveying crews. That's 8 people there for 14 months, over 100 months in the field. While we would have done it in 10 months with 1 operator. And the quality, the fact that 4% of the markings were not sufficient enough, and the piling of the solar farm had to be redone. In the 10,000 points that we did, only 2% were redone. And by using automation and digital product, we provide real-time updates to our customers. We saw also productivity increase in various activities, in this case for trenching. Instructions are now clear by using smart stakes, which I'll discuss more deeply in the next slide, with a goal and vision to finish projects sooner at lower costs. And let's talk about the smart stakes. Our stakes have a chip, an NFC chip, that we code with instructions based on the blueprints. So by uploading the CSV file or the DWG or DXF, whatever you may need into our software, choose the coordinates you want to lay out. And if we know it's a linear job, like this case, for instance, laying out a pipe, at first information you see will be digging. When you press complete, the next instruction will be fill sand. And we can use an open API with real-time updates to the PM, to the different subs, and we log everything. Instructions are clear. In this case, installing a pipe, what's the offset? What's the diameter? What type is it? Everything is here in order to convey the information as clear as possible to build accordingly. And we're looking at renewable energy. Like I said, solar farms require thousands of piles, roads and rail, very long linear job sites with many elements on it, striping in the end, but there's so many earthworks and railing and sidewalks, stop sign, electricity, utilities, you name it, it's there. And in ports and pipeline, we've seen actually one of the job sites as well for foundations. We see a lot of markings there, a lot of different utilities, and it works on these job sites for us. We already deployed this with 10 customers in the US and Japan, and we have 2 purchase orders for later this year. So thank you very much for this opportunity. I'm happy to answer any questions you may have later during this event. And you can shoot me an email at tom@civrobotics.com. We're based in San Francisco and working all over the US right now. Thank you for this opportunity.
Great. Thanks so much, Tom. It's every time I see you present, I'm always amazed at what your company does. So next up is Alok, and Alok is going to talk more on the building operations side. And the one unique thing about Alok in a positive sense is that he's a technologist that came to the AEC industry as compared to Ali, Tom, and Jim, who came within the industry to solve the problem. So it's really great to see how Alok will be sharing his perspective on building operations.
Thank you, Zig. Appreciate the opportunity. Nice to see so many people on the talk. Maybe a little bit of background on myself and the company before I dive into this presentation. As Zig said, unlike the other presenters, I do not come from this industry. My background is mainly in retail and from a technology side of things. So apologize in advance if some of the nomenclature or descriptions that I use may lack the context that you might be used to. In terms of the phase of the life cycle of a build space that we are more interested in covering at Qopper, like Zig said, we are in the operations side of things. So our focus isn't as much on design or the build phases of the projects. But in terms of the amount of information and data that we generate from an operation perspective, there is a tremendous amount of value in the information that we're able to capture and generate in the operations of sites that can then be leveraged during the design and build phases. Also, as you start to get into operational aspects of things, you do start to pay a lot of attention to domain-specific nuances. So in terms of the kinds of spaces that we are currently set up and operating, we are, given my background in retail, we're primarily focused on retail and retail type spaces. So whether it be convenience stores or grocery stores or restaurants, hotels, museums, libraries, schools, etc., are things that kind of come next. Specifically within these spaces, the kind of use cases that we cover are in 5 specific categories. So they go from employee activity that happens on site, to customer activity, to point of sale related activity, to energy management, and then food safety. So as you go from vertical to vertical, you'll see a lot of overlap. Obviously, a lot of these places do have employees, so the needs around workflow management, employee management, etc., are fairly similar and consistent. Most of them have some sort of customer activity, so there's an opportunity to feed in a lot of customer-related insights and information into our platform, and then kind of leverage that to see how a space is catering to the needs of customers on site and on location. Point of sale is more important for the operators that are in retail, and it has to do with how the customer activity is actually converting to commerce activity. So usually, in terms of conversion flow, etc., that we put together for our customers, this kind of data is very pertinent and very useful, because when it comes to bottom line of them running their businesses, a lot of the metrics are driven by what we get out of the point of sale systems. Energy management and food safety. I'd say energy management is probably fairly generic as well. It spans verticals, and perhaps the data that we capture over here is very pertinent for the design and build phases where people are focused on building green and using that as a design consideration for designing buildings. Food safety probably less, is a little more niche. There's several convenience stores that have quick serve restaurant type capabilities, as well as obviously a lot of the restaurants. In terms of specific endpoints from where we capture and collect information, there are several integrations that we have, and we collect a lot of this data in real time. So traditionally, of course, there's a spectrum of sensors from where we pick up information. So there's over 70 sensors that we are able to collect data from, ranging from temperature, humidity sensors within devices, so refrigeration units or hot cases, to ambient temperature and humidity sensors, to door open close sensors, which give us a sense for how often people are going in and out of spaces, to current and voltage sensors, which pick up a lot of information related to energy. And then people counter sensors are more infrared and thermal type sensors, and they're able to track doorways and bidirectional flow of people, and that kind of feeds into the same platform. A new addition to our portfolio of devices is what we refer to as this touchless kiosk, and that is particularly pertinent in the COVID era, where people don't like to touch things. Initially, we're using that capability for employee safety, so primarily for clocking in, clocking out employees without having to touch anything. So that doesn't entail aspects of facial recognition, or in some cases where we haven't been able to, we don't have enough data to train around facial recognition, we can do QR code based clock in, clock out as well. We measure temperature at the same time and are able to feed into various kinds of alerting and reporting downstream capabilities around this data. The handheld terminals are specific to certain kinds of employee activities, whether it be in the kitchen, or whether it be in the forecourt, or whether it be in the retail area. It gives people a dashboard or a view of what's going on in that particular location in real time. To the right on this slide, I have various tools that we give our customers access to. Alloy is more of a dashboard and an operational tool. Forge is used more to set things up, and most of these capabilities are available on a mobile tool as well. Net, the kind of data that we collect, whether it be from sensors or other sort of ambient sources like weather data or traffic data from various sensors or kiosks, all feeds in through edge systems into our cloud, and then is available for use cases around monitoring and diagnostics, operational workflows, and the reporting and analytics around it. There's several predictive capabilities, whether it be around anomaly detection or whether it be around just predicting conversion rates, etc., based on sites, etc. We have had conversations around how this data can be pulled in more upstream and fed into systems and that are being designed, but we haven't operationalized that into our product yet. So happy to have that discussion with anyone should there be interest in pursuing that. Some of the things that we do with that data today is more around metrics like mean time to resolution, around break fix type activities that happen in the site, conversion activities, which is around consumer from driving up to a store to entering the store to being able to transact in the store. We can do store over store comparisons around payments and see category by category comparisons. Interesting insights that we've picked up are we've seen as convenience stores start to add capabilities around drive-through or food. We've seen more foot traffic convert from people coming in just to fill gas to getting out and walking in the store. And we're able to accurately track and report on that. And then when we end up doing store-over-store comparisons, we can correlate that to profitability of a given store, given the kind of capabilities or services that are available at that store. Around energy management, when we pick up data from various kinds of appliances and devices, we're able to do relative comparisons to see how certain kinds of equipment compares with others. And we've noticed that that varies from site to site. It is correlated with weather patterns. So on a warm day, there is more energy spent on air conditioning. It varies from equipment or age of equipment. We've seen older equipment has lower performance. So those kinds of insights we can deliver to our customers, and that also ends up impacting energy costs and helps them with savings. In terms of just quantifying it, so employee activity is a fairly significant component of the cost of a lot of these locations, and we're able to, through data and analytics, help favorably impact this number. In terms of customer activity, it's primarily conversion. A lot of the marketing folks are very interested in tracking how the conversion numbers look like, store over store, week over week, day over day. We're able to provide that level of analytics. Point of sale management ties into sort of overall operating profit, so we can see what kind of things drive revenue up or not. And then energy costs is a fairly significant cost as well. And in several cases, it's one of the top 5 costs in the store, and we're able to quantify so what kind of things are able to drive that number up or down. So that's all I had. A couple of quick slides to go through. I do have a more detailed demo in a presentation, so I know we probably have an opportunity to get into a breakout room. Happy to continue the conversation there, or feel free to reach out, and I'd be more than happy to walk you through more details of the product. Thank you.
Yeah, great. Thank you so much, Alok. Always interested in seeing how your technology is embraced, and it's nice to see that you're in so many different verticals now. Last but not least, Ali, can you come up to start sharing your screen? And Ali is going to talk about his technology that addresses building resiliency. The buildings that we are designing and building today will last over 100 years. They don't weather the same during that 100 years, so we need some sort of technology to address how they age over time, and I think Ali is going to share what his company does.
Perfect. So thank you, Zig, for the intro, and thank you so much for the CIDCI team for putting together this panel discussion regarding using data throughout the life of the assets that we all use on a daily basis. And also kudos to my fellow panelists for how they're tackling the issues in the industry by using these novel technologies. So great job, everybody. So today, as Zig mentioned, I'm going to talk a little bit more about how it's possible to use data and with a combination of civil engineering and artificial intelligence in order to really improve the safety and resiliency of civil infrastructures, and how literally we can bring it to the way that it should be in the 21st century. So with that, I will start my talk. So we can all agree that civil infrastructure provides the foundation of our society to operate and thrive. Yet infrastructure around the globe is in terrible conditions. US regulations requires biannual inspection of all the 600,000 bridges that we have in the country. Still, 56,000 of those bridges are structurally deficient, with the most famous one being the Brooklyn Bridge here in New York City. On a daily basis, more than 200 million people cross bridges at risk, and shockingly, there's a bridge failure once every 3 days. What you can see in this picture is one of these famous failures in Minneapolis, which killed 13 people, injured 145, and it was a $100 million settlement. Current methods of inspection, assessment, and management of infrastructure is precarious and outdated. Engineers have to walk, climb, and use snooper truck to assess miles and miles of infrastructure and use their naked eyes to detect damages and take notes on a piece of paper. Then they have to go back in the office and go through decades of assessment reports and compare it with their field notes to see if the asset is deteriorating or not. These poor and insufficient information feeds the maintenance plans, and as a result of it, trillions of dollars of infrastructure budget are poorly spent and people are getting killed. These problems are hitting the pockets of asset owners, engineering firms, and insurance companies. I'm Ali, CEO of Aren. We are bringing our patented technology to tackle this problem. We are building a business-to-business software as a service civil infrastructure management platform to help both asset owners and engineering firms to assess and manage infrastructure using a unique combination of machine learning, computer vision, and civil engineering. In a nutshell, we are building a digital health record of the asset, a digital health record. Our goal is to reduce the risk of failure while extend the service life of these assets. So let me walk you through how our product actually works. First, our software aggregates data that the client provides from drones, laser scanners, and other sensors available on an asset such as this one, which is the 60-meter long bridge, which is one of our projects in the Netherlands. Second, our platform can automatically build a high-resolution 3D digital twin of the asset with unprecedented accuracy, capable of capturing millimetric details such as the crack that you can see on the bottom right-hand side corner. What you see on this slide are the screenshots of the 3D model. So let me emphasize, these are not 2D photos. This is an actual, accurate 3D twin of the asset. Third, by using artificial intelligence, our platform can automatically detect and quantifies severity of different damages such as corrosion and cracks. This is something that we can do in different materials and in different assets. And of course, all of it happens in 3D and in the context of the asset. And there's more. We have the capability to quantify changes in time to see how a damage evolves in order to be able to calculate the rate of deterioration and predict future structural changes. In other words, we are providing a historical timeline of the condition of the asset. And last but not least, actionable insights. Our SaaS platform can provide data-driven maintenance and capital allocation plans in order to reduce the risk of failure while optimize the spending across the asset portfolio. In our case, data collection is as easy as taking photos with your iPhone. Everybody can do it, which makes our solution scalable. Now, instead of spending weeks to assess the health of the asset, now the engineers can do it within the matter of hours. Now, instead of having access to the asset once every year while they're at the site, now they can get back to it virtually as many times as needed from wherever they are around the globe. Our product is sticky because it is mandatory to conduct a structural integrity assessment of all the assets through the decades of their service life. In addition to that, our technology is hard to replicate, and it's backed by 10 years of R&D and 3 patents that we have. So our clients have used our technology to assess the condition of different asset classes across the globe, from bridges in Alaska to dams in Maryland to building facades in New Jersey. In all of these cases, by using our technology, they were able to significantly reduce the time of assessments by up to 50%, saving them tens of thousands of dollars, but more importantly, saving them millions of dollars from costly litigations and poorly spent budgets. So let me show you the technology in action in a couple of different asset classes. So what you're seeing here is a chapel here in New York City, which was built in 1888. As many of you should know, using drones in New York City is forbidden, so you cannot use it. So what does happen here is our client actually used a point-to-shoot camera off the shelf, 16 megapixels, so nothing fancy or high resolution. They went around the object, which in this case was a chapel, took almost 200 photos in a span of 30 minutes. And by using that data and that data alone, so no blueprints whatsoever, we were able to create this highly detailed 3D twin of the asset automatically that you can see all the nitty-gritty details on the asset. But most importantly is that actionable insights. By running our AI algorithms, we are able to detect deficiencies that we have on the building facades, for example, the missing brick, and not only we are able to identify, but we are quantifying that, as the red color are showing no damage, and as you go to the blue color, you're showing different levels of severity of the damages happen on this building facade. In another case, using our technology, in this case for the signature bridge in northeast of US. So the goal here was creating what we call a crack map, which is documenting all the cracks. So the client provided us 400 photos. By using that photos, we were able to create this highly detailed 3D model that you can even visually see the hairline cracks. But all this purplish color here are showing the results of our AI damage detection that helps us to find all these damages, all these cracks in almost real time, create this 3D model, and now everything is in context, so you know exactly what is the pattern of the crack, which is from the structural engineering point of view. It's important to know the pattern, but most important than that is that for each and every of those cracks, we have the quantification and understanding of its characteristics. So what's the length of them? What's the width of them? And also, when you do this inspection and assessment, and as you should do in different time steps, now we can see how things are evolved and how things are changing down to a granular level of a crack. Regarding our beachhead markets, right now our markets are building facades and bridges in the US, which account for $18 billion. Worth emphasizing that our goal is to optimize the trillions of dollars that we spend on infrastructure on an annual basis at a global level. We have started in early 2019, and currently we have a sales pipeline of $1.5 million across North America, Europe, and East Asia, and we are on track to bring 1,000 assets to our platform. Right now, we are working with major global asset owners, such as the Dutch Ministry of Infrastructure, and also a major global industrial firm who has access to 10% of all the bridges across the globe. Our team has PhDs in computer vision, machine learning, and civil engineering, and has worked at top-tier consulting engineering and management consulting firms. We are proud to have Cornell Tech Jacobs Institute, Metaprop, and National Science Foundation as our investors and advisors. We are pushing the boundaries to improve the safety and resiliency of infrastructure around the globe. I invite all of you to join us in our mission. We are Aren, and thank you so much.
If all the panelists can talk about what were some of the cultural hurdles that your technology had to navigate around, because many of us, I'm assuming that are on the call, think your technology is really cool and awesome, but ultimately culture eats technology for lunch. So can you talk about some of the human factors around the technology part? And Ali, why don't we start with you?
Absolutely. So, of course, there are a couple of challenges when you're bringing like AI to old school industry, especially like structural engineering and all that kind of good stuff. I think there are like two main things. One is the fact that whenever we're talking about AI and like all those kind of good stuff, sometimes, you know, people who are like, especially in this old school industry, such as construction and civil engineering, you know, you see some pushback from them because, I mean, they don't understand it. They haven't been trained to understand AI and all of that. So there's a lot of, you know, walk with them hand in hand to make sure they're understanding what we mean by each of any of the stuff that we're talking about. But most importantly, in some of our early discussions, we had these conversations that everybody's thinking about, hey, like, you want to replace engineers, and that's not going to fly with the industry. So even within the conversations with them, we had to start talking that, hey, this is not about replacing. This is all about augmenting the process. This is about providing better tool, more data, more thorough analysis, that now the engineer can actually do the job better. Because at the end of the day, they're taking liability. When a PE licensed engineer signs something that the bridge is safe, I mean, it better be safe. So we are providing information that with better knowledge, they can say things are safe and things are going to stand for a longer period of time, and even coming down in terms of repairs and maintenance. So it's a more data-driven maintenance and all that kind of good stuff. So it was like, even within the conversations with them, we had to walk them through the fact that we are not in the business of replacing engineers. We are just we want to augment the process and improve the efficiency, if you will. So I think that was like one of the key things.
Okay, great. Alok, can you share some thoughts?
Sure. Yeah, some sort of pertinent thoughts as far as or interesting anecdotes from the COVID experience that we're all going through. So I think, like Ali, we were anticipating similar challenges, because when you're going into an operational environment, there is a natural tendency to push back with regards to, hey, you may be taking away my jobs. Because one of the big sort of ROIs that we present to our customers is savings, whether it be labor savings or energy savings. And in case of labor savings, it's potentially impacting the workforce. So that's what we were prepared for. That's what we were bracing for. With some of our customers, we saw an interesting curveball come our way, especially in the last couple of months. We started to see actually an embracing of our technology for a reason other than what we were presenting. Because what we were told that they started to notice that a lot of their workforce, so around the time things slowed down, shut down, reopened, etc., chose not to come back to work. So they started to have problems with just being able to staff their stores and be able to have enough people to man the stores. An interesting consequence of the checks that everybody got, it made more sense for a lot of these minimum wage people to sit at home and not to work than to work and then expose themselves to a potentially unknown quantity with regards to the virus. So they started to look at us and the capabilities and the tool that we brought to the table as critical to their operational capabilities to help them get more done with fewer people, rather than for us to kind of look for efficiencies with the existing workforce. So that was an interesting sort of outcome for us. There are other angles that we have in talking to our customers, and with some of the touchless kiosk type capabilities. There's employee safety type issues. So there, again, we've seen a strong interest in wanting to embrace these solutions. So there we've had a positive outcome as well in terms of people wanting to adopt and embrace this technology.
Great. Tom, do you have any insight to share?
Yeah, I would like to share something about liability. That's an issue that comes often to the table, because when we mark coordinates, it has to be bullseye. So if it's not bullseye and we're the one to blame, I can't have that on my conscience or on my invoice or insurance claims. So basically, what we do in order to show our customers that this is actually works well, we go and perform this on the job site for a long duration of time, and they can verify as many points as they want. And I'm fine with that, because we've done close to 100,000 points by now, and it's up and running. The last thing I would say, Ali also mentioned this as well, we get a lot of, the community sometimes is forward thinking about automation, but then when it comes to automation, that on some level does replace manpower or hours spent in the field. It's going to happen sooner or later at some level. So there's some pushback from some individuals, while others are the opposite. And we're trying to provide them better tools to be more efficient. We're not trying to replace their work. We're trying to just give them tools to do it faster and not do the, let's say, dirty work or the grunt work.
Okay. Last but not least, Jim, do you want to share your thoughts about this question?
Yeah, I mean, I think, similarly I think we were braced for the perception that, hey, you're trying to replace an architect's expertise, or you're trying to kind of put a scorecard against what they're doing. I think we've been pleasantly surprised that really what architects see this as is something that allows them to align their goals with their customers quicker and to kind of really be in charge of shaping the conversation. So, when you have a design, it's never going to be this thing where there's a perfect solution, but really the architect's role is to be able to go in and to kind of navigate the tension between, having a patient have privacy and a nurse being able to supervise that patient. So by having the data in the architect's hands to shape that conversation and to kind of put forward their own expertise, they can really shape that conversation. So yeah, I think the potential barrier is being seen as a kind of inevitability that that we're going to spit out an inevitable answer for people, where really we're putting the data into people's hands so that they're empowered to make those decisions and navigate those negotiations.
Yeah, I think you mentioned the term the democratization of data, which I really love. And yeah, I think that's really true. So we have one question from the audience from Chris Lupkaman. I think this question is more for Tom, which you touched on, and Ali. Who carries the liability for accuracy of the information which you're determining, i.e. cracks and or advice you're offering?
So regarding, I mean, that's a good question, and we get that question a lot. So regarding the liability and who carries that liability, our clients are the consulting engineering firms who are actually have the contracts with the municipalities and government agencies and the asset owner in general. So at the end of the day, it's that engineering firm who takes the liability and that PE licensed engineer who sign things. But what happens there is we've put ourselves, or we frame ourselves as a tool that really helps them to do their job. So we are a SaaS platform. We are a software solution. We are not we're not doing a service, if you will, or tech-enabled service. And what happens with our clients, just because at the end of it, also they have to make sure that what we provide is correct. So there are two things happen. One is mostly, I mean, at max 5% of the damages that we detect in the field, they also make sure that we provide the right dimensions and characteristics of them. So like 5%, they do this QA, QC, if you will, of the way that we are doing that. And that 5% is sort of like industry standard. And like DOTs are fine with that. And the other thing is, even there are studies by Federal Highway Administration, Department of Transportation, and even talks with the clients that in most cases, the engineering firms are only able to detect between 30 to 40% of all the damages, because it's a very manual and labor intensive job. So we are providing way more information with a way higher accuracy, which makes them happy. So now instead of like having only 100 cracks or 10 spallings that they found, we provide way more than that to them. And again, as I mentioned, they run this QA, QC and check like 5% of the damages that we detect just to make sure everything that we report is accurate. This gives them like more confidence, if you will.
Okay. So this is a question maybe for all of you. Who are the most resistant to implementation of your technology, and what is your strategy to answer their concerns?
So I can take that, I can start with that one. So early on in our, customer discovery parts a couple of years ago, we were like, hey, we have to go to the asset owners. Like thinking about bridges, DOTs, thinking about dams, like U.S. Army Corps of Engineers, and those kind of asset owners. And very soon, not only like being a B2G business, it's not the best setup for a startup because of long sales cycle, but we could see that like people at the government level, they have this tendency of not working with startups, not working with high tech, don't want to change the way that they're doing stuff, and the way that they get incentivized is different from private sector. So very early on, we've understood that you have to move towards private sectors and talk with them rather than talking with government agencies.
All right. Anyone else?
I would add that very often that we found in the beginning that we try to reach out to customers via innovation is not the fastest route. So if you have boots on the ground and able to, just say, look what we're doing, and a roadshow, we're on the road, we're doing demonstration, we're doing an online demo. That brought more business in and be able to answer questions much faster and clear things up. So by able to skip the innovation sometimes and go straight to the biz dev or the actual PM, that's something that I learned on the job.
Wow, what a great morning or an afternoon, evening. I think this has been really fantastic. So I want to thank Ziggy for pulling that together. Fantastic job. I think I want to also thank Monica for your adroit manipulation of the groups to get us into those into the right places. I think that's really really fantastic. You know, I'm always amazed at the things I didn't know existed. And it's always been my job for the past 20 years to try to keep track of what's happening that's new. And this is why the CIDCI and organizations like this are so critical, where we can see that place and that space in between practice and research as new things bubble up and the new challenges that we're facing are brought to light. And this is this great sort of meeting point of practice and brilliant minds. And so I'm coming away from this ready to go have a glass of wine and eat some dinner and being inspired, as most of you are about ready to go have a coffee and a bagel. This is beers and bagel time. So I want to thank you for that. For those who would love to become sponsors who are not yet sponsors, make sure you do that. We also want that tomorrow. Margie O'Driscoll, CIDCI's, I'd say, the person who makes everything really work or happen. I mean, she's the one who happily corrals us. Let's just say that. Let's put it in a very positive way. Between she and Monica, we've got that. She's going to be interviewing Michael Bednark about his Brooklyn-based company's complete pivot to develop life-saving PPEs in the midst of the pandemic, and to also talk about what COVID-19 has taught us all through innovation. I think for all of us, this has been a trying time. For some, it's been wonderful. For others, it's been hell. And but for all of us, our lives are and will continue to be impacted. So with that, I would like to say thank you again for all of you for tuning in today. And thank you for your inspiration. And thank you for the organization. So I hope you have a wonderful day. We'll see you soon. And thanks again for our sponsors. Without you, this would not work at all. So, Stuart?
Hey, no, thank you very much. Look forward to tomorrow and appreciate everyone today. Just fabulous. And I like to comment about I'm always amazed at how much I don't know. So thank you.
All right. Goodbye, everybody, and have a great day. Ciao, ciao.